Welcome to the cloudonaut podcast. We are your hosts, Andreas and
Michael Wittig. We have been building on AWS since 2009. Here in the podcast, you can follow along as we develop products like bucketAV, marbot, and HyperEnv and learn from our practice. This is episode number 88, and we are recording this on March 14 in 2024. So in case you're watching this live on LinkedIn or YouTube, feel free to ask your questions, and we will answer them either directly or at the end of the show. So, Andreas, what topics popped up during the past 2 weeks for you that you want to share with us?
Yeah, so the first thing I want to start with, Michael, is each year there's a survey by Peter Sankauskas, and he's doing basically a community survey. And this is called Answers for AWS. And I found that quite interesting. I looked into I participated in the survey a few months ago, and then now Peter sent out the summary to all of those who participated. So I checked out what's going on there, and I found it quite interesting. So maybe a few things that got my attention. So they are basically asking the community about which AWS services do they use, which of those do they like. So basically that's, would you use it again? Do you plan to use it, and questions like that? This is how they try to find out about the positive negative split and basically who is using which service. And the first category was infrastructure as code. And what I found quite interesting is that the most used infrastructure as code service, Michael, do you have a guess which one is the most used tool or service?
I hope CloudFormation.
Yes. Do you really hope that? Yeah. So it's cloud. It's definitely CloudFormation. So 85% said they use CloudFormation. So that's
85.
Yeah. Of those who, the service is probably,
okay.
Michael. So, but of those people who use infrastructure as code, 85% use CloudFormation. Yeah. And then the second place is Terraform OpenTofu, with 72%, and then CDK. So I didn't expect that actually. So it's 57% use CDK as well, or have been using it. So that's quite a lot of, and I found it interesting that those are important. And Ansible, by the way, Ansible gets 55% as well. So those are the four major ways to basically do infrastructure as code. Okay. And what is also interesting, I would say, is so if you go into the positive negative split, so would people are they planning to use it in the future? Do they like it? So that's basically what they are saying here. And their Terraform is the tool that has the most positive vibes here, so to say. So many of those who use it will continue using it. Only 47% of CDK users would use it again. So this is less than OpenTofu, Terraform, and CloudFormation. So I don't know if that says something, but yeah, at least I think the major tools, Terraform and CloudFormation, are popular, and people are also more or less happy with that. But also CloudFormation, there are 30% that say I would not use it again. So this is kind of a important negative trend here. But I found it quite interesting. And then the other important category for us, Michael, is the CI/CD area. And it's very good news for the product that we are building with HyperEnv. The good news is that GitHub Actions is the most popular choice those days. So it's the winner in usage, and also if you go into do people like it, will they use it in the future? It's the absolutely clear winner is GitHub Actions. So the other tools like GitLab, Code, all the code services are not getting the same traction here. So I think we are betting on the right horse here at the moment. So for using it ourselves and also building a product on top of that. I found that interesting. And then maybe the last one I want to dive into is containers. And here it is actually, it also fits quite with our own thinking and our own thoughts about the situation. So the most popular thing is ECS and Fargate. and EKS, self-managed Kubernetes. This is all not that popular, I would say, anymore. And also, I would say also it's getting more negative ratings or feelings or on those services. So that's interesting as well. So again, I think ECS and Forgit is definitely the way to go. Still the way to go for quite some time now. Okay. Yeah, so that is interesting. So check out answersfromaws.com if you're interested in details. Maybe participate next time in the survey next year. They also started, that's interesting for the future, they started to have a trend over the years in the results, but I think it has only 2 data points now. So it's not yet that interesting, but over the years it will be interesting to watch how things evolve.
All right.
Cool. Okay, Michael. So the next thing, so I think on Monday, so I started to dive into a topic a little accidentally, I would say. so because, so this was all basically brought up because of a change of AWS networking. And so over the years, when we try to set up cost-efficient AWS networking infrastructure, that's how I would call it, then our go-to solution was to deploy the workloads to a public subnet, restrict traffic with security groups and network ACLs, and basically make sure that all the parts of the system can reach out to the internet over a public IP address. Because by doing that, you didn't pay for the NAT gateways, you didn't pay for the additional traffic costs going through them. So this was really our go-to solution for building cost-efficient architectures, network architectures on AWS. And for example, with bucketAV, that is our recommended option to deploy bucketAV. We have other options with NAT gateway and stuff as well, but the most cost-efficient way is doing it like that. And then the problem is now that AWS introduced the charge for public IPv4 addresses. And that changes the game a little bit, because now the whole thing doesn't work that way anymore. At least you have to pay for each public IP address, so this adds extra charges. And I was thinking about for quite some while, so what is now the most cost-efficient way to deploy workloads on AWS that need to reach out to other endpoints over the internet? And I was thinking, so maybe I can find a way to get a cost-efficient way that does not include NAT gateways, because that's what I'm basically trying to avoid. And then I stumbled upon one project again, so from Ben Whaley, who by the way, wrote the first intro for our AWS in Action book many years ago. So he was, a few years ago, he published AlterNAT. So this is a project that basically deploys EC2 instances acting as NAT instances. And then they have Lambda functions to monitor those and auto-scaling groups. And then they basically update the routing table of the VPC subnets according to that. So that looks definitely interesting. It's way cheaper than when you use a NAT gateway, but you have the problem of scaling those instances, traffic spikes and stuff like that. So I thought maybe there's a better way. And the next thing I ended up on spending quite some time with before I finally found out that it's totally the wrong direction is I looked into the gateway load balancer, Michael. And so what do you know about the gateway load balancer, Michael? So it's really a niche thing, I would say.
Yeah, so I don't know much. So I just know that it somehow can be used as a route in your route table, like an entry, endpoint basically.
Yeah, exactly. And so the documentation about the gateway load balancer is very minimalistic. So that's the first problem. So to understand what's really the purpose of this thing is not too easy. And I think it has been announced 3 or 4 years ago. It's really been there quite some while and never stumbled upon it, never used it, never did anything with it. And as you said, the gateway load balancer works similar to a network load balancer. So you set up the load balancer, you create a target group. It speaks a specific protocol between the load balancer and the instance. So far, so good. And then you can create a VPC, an endpoint service pointing to the load balancer. And then the special thing here is if you then create a VPC endpoint for the endpoint service, you can use that endpoint as an entry in the route table of the subnets. So that's something you cannot do with other endpoints. It's a special thing here. And I was quite so this was really cool because I thought, oh, that sounds great. Maybe I can build a way out of my VPC to the internet based on that. And the name Gateway Load Balancer implied to me, okay, there's a gateway, so that sounds like something I can use to get out to the internet, right? And I tried to get that working, and I was reading through some code, through some sample implementations of that protocol that is used there and stuff like that. And then after a few hours, I found out, oh no, that's totally the wrong direction. So the thing is, the gateway load balancer has a very, very specific use case. It's only basically to integrate firewall and intrusion detection systems into your network. So if you have, I would say, those well-known good old brands from the on-premise area, so Cisco has stuff like that, you can basically send a copy of or you can basically send the packages through such a system by using a gateway load balancer, and the firewall is basically just looking at the headers, so the IP addresses and some more information, and deciding is that denied or allowed. And that's the only thing you can do. The traffic is still flowing through the old ways through the network. So that's basically how the whole thing works. So this was a bummer. So this doesn't work like I expected it to work. So I tried a few other things. I thought about maybe VPC endpoints with a network load balancer. Doesn't work as well because you have to do the source destination check needs to be disabled, and that's only possible for EC2 instances. So for the NAT instances that we've been doing, and so on and so on. I think one option that I currently think of is IPv6 only VPCs, and then using those outbound only, how are they called? Outbound only internet gateways or something for IPv6.
Mm-hmm.
So this is interesting because that's basically a NAT instance. So it's giving you a way to the internet, but only for outbound traffic, and it's doesn't incur any charges. So I think that's an interesting approach. The problem with that is then you can only reach destinations over IPv6, and the first time you're stumbling upon an IPv4 only endpoint, you're then totally lost. So that's probably not very practical those days. So yeah. So I want to close this. So I'm not really happy with the current situation. So the thing is, I think the networking, setting up a network on AWS is now too cost expensive for small workloads and not the fancy enterprise stuff. And I'm really looking for ideas how to build a cost-efficient AWS network architecture. So if you have any ideas, feel free and let me know. I'm really interested in finding ways that do not require a NAT gateway and do not require public IPv4 addresses. So I'm looking for ways to get that working. I don't know if there's anything, but that's what I'm currently onto a little bit.
All right, Andreas. So that was quite an investigation into the topic, right? So, but unfortunately, no results so far. So I was last show, Andreas. In the last show, we discussed something where I kind of quickly said that okay, we could speed up our acceptance testing on AWS by just running the test in multiple AWS accounts. So that was kind of something I said in the last show. And in the last 2 weeks, what I actually did is I implemented that idea. So let me provide some context. So we spin up CloudFormation stacks in larger amounts to perform acceptance testing of our products, for example, bucketAV, but also for open source projects like our CloudFormation templates. And what we do there is basically we validate that the templates run in every region on AWS. And for bucketAV, we also do some more sophisticated testing. So we, for example, check if the malware scanning is actually working, if a file is uploaded to S3. We check that reports are generated, all kinds of things, because we use a lot of AWS service to make everything work. So that's just kind of the last line of testing, right? This is then when it's deployed to AWS. You also have like many other tests run before, but this is kind of the most expensive and most time-consuming tests. So the problem is, okay, it takes longer and longer and longer the more tests we add. We can also not run so many tests in parallel because we will run into API rate limits. So for example, the CloudFormation API has very strict rate limits, but also if you start spinning up a lot of VPCs at the same time with CloudFormation, then CloudFormation will run into rate limits from the EC2 service, for example. So for example, you cannot create 50 VPCs at the same time. That's not going to work because you will run into rate limits. So the idea in the last show was to actually distribute the tests across multiple AWS accounts. Because we actually already use many regions in an account, we cannot spread it across regions, so we really have to spread it across accounts. And that's actually what I did. So it was a little bit harder than I expected, but basically what we do is now, when a test is launched, we randomly pick an AWS account, and then we assume the role. By picking an account, I mean we assume a role into that AWS account, and then we run our tests there. And when we started, we used JUnit, but I switched to another test framework in the Java world called TestNG in the meantime, because I was running into problems with JUnit as well. And TestNG basically parallelizes the test for us, and it also captures data that is then put into the test report. And this data, for example, is logs from CloudWatch logs. It also includes the CloudFormation events and all kinds of stuff, so that because we delete everything after a test, so that we have kind of a way to understand what was happening by capturing all that output. So that's kind of what we get now. And now we have test results that they include all the information, and also they run in parallel, which is great. The only last problem that I have, Andreas, is that we have tests that are running in maybe 15 minutes. We also have tests that take 90 minutes to run. And I try now to focus on the very slow ones. For example, the 90-minute test was one that created a VPC, and then it set it up 10 VPC endpoints, and it didn't create them in parallel. It created them one after another, and that was taking like a lot of time. So I already kind of investigated a little bit there to speed that up as well. And then I think we can have a test run in under an hour, and we are coming from 4 hours. So it's significantly faster now. And we are running on 5 accounts at the moment, Andreas. And I think we could even spread that out a little further if we wish to speed up things more.
Yeah, that sounds really amazing. So, Michael, to be honest, I've never seen, so you really, so besides implementing the multi-account feature, you did really a great job in implementing the acceptance tests, the integration tests for that. And actually, I've never seen a test suite that covers a multi-account scenario before. So really, really cool, really cool. And because that is also giving us the flexibility to run the tests in multiple accounts in parallel. That's really, really cool. So to use many accounts for testing, this is really, really interesting.
So I'm very proud, Andreas. So the acceptance test suite is, I think, the most valuable thing that we created, and I think it is more complex than the product itself.
Of course it is, yeah.
And it is really, I mean, it is slow, but the good news is that when we create a new release, and I just created one in the morning, I'm very confident that the product is still working because I know that all those tests are running. So yeah, it's really great. And as you said, the reason why I actually implemented this is not because I was kind of bored. The reason is that I was working on a feature in bucketAV that required more than one AWS account for a test, because we now ship multi-account with IAM roles in the next days. And I added tests for those scenarios. Before that, we used a different approach for granting access across accounts by using bucket policies. And now it is really using IAM roles, which is easier for our customers to use. And so I implemented that for a test. And then I thought, okay, I just remembered our conversation from 2 weeks ago. And I think it's not very, very far away that I have like tests running on multiple accounts because I already had implemented the 2-account way where I had to kind of define in which account I'm running. And so I kind of implemented everything, and then I just had to add the random picking of an account, and then that's it. Besides all my issues with JUnit and that things which really required 1 week of work to get everything back up and running. But this was kind of the initial reason why I actually looked into it, was that the multi-account testing was needed now. All right.
So Michael, I've also learned something from my working on a new bucketAV feature. So bucketAV runs on EC2 instances, and it has been running on typical Intel or AMD processors for many, many years now. But we are big fans of the ARM processors, so the Graviton instances, because we really achieve very good results from switching to those Graviton instances in the past. And so one interesting learning I had this week is, so in the past I have migrated some, I would say, simple web applications and stuff like that from the one platform to the other. And this was typically quite simple to do. Yeah, if you have, for example, I don't know, you have only an Nginx running and serving a few, I don't know, a PHP or Ruby application, what have you, then it's quite simple to get that running on ARM, because basically all you do is you run your Packer script to build a new AMI, and as long as you install all the software from a well-maintained Linux repository, for example, from Amazon Linux, then this works out of the box without any further doing. Same for Node.js applications that we use quite a lot, or Lambda functions as well. It's very easy to switch just to the other CPU architecture. But so this week I found out 2 things when trying to do the same for bucketAV. So first I tried it for cloudonaut. And then the problem there is, so this is an open source antivirus engine that we use, and we basically install the engine itself from a repository. And I found that the repository is basically, it doesn't include the ARM builds that I need, at least not in the version that I need. So it includes very old versions built for ARM, but the other versions are not available. So that is one thing. So it only works if you have the packages in a well-maintained repository, I would say. And then the other thing then, when trying the same for Sophos, where we need to install the application, the engine ourselves. So there I found out it's very hard to get things up and running if you have dependencies and libraries and binaries that all need to run on Graviton on ARM. So that's quite a challenge, actually. So it's nothing to do in 15 minutes. It's something you need to fiddle around with quite some time. So that's what I basically learned. So far I thought this is basically a no-brainer and something I do in an hour. And now I know there are also areas where switching the CPU architecture can be a little more challenging. Keep that in mind. But I think still it's interesting to check out Graviton because of the cost and performance improvements that we expect. Yeah.
All
okay,
right.
Michael. So last but not least, let's end the show with our with the final section, which is the AWS news check. So I've been going over the announcements over the past 2 weeks from our last recording, and I've picked 3 news, and I want to hear your reaction and thoughts on it, and I have maybe some additional news, additional info on those news. So the first one is experience up to 40% faster stack creation with AWS CloudFormation.
Yeah, that's great. And I must say this is kind of a funny coincidence, because I mean, I was working on making our acceptance tests running faster, right? And I mean, if CloudFormation is 40% faster, then our acceptance tests are also 30% faster. So I'm not very sure if all these optimizations are kind of because of me, or is it because of CloudFormation. I still have to figure that out. But yeah, it's a great kind of news, Andreas. So how does it work?
So basically what they have a new event, which they call configuration complete instead of create complete. Because, so in a blog post that I was reading about, the whole thing is, so CloudFormation uses internal feature to basically check when creating a resource. CloudFormation does not only send the API call to create the resource, it then tries to check whether the resource is ready. So that's probably totally different for the different resources, but they make additional API calls to wait until the thing is stable or ready to use. And what they're now doing is they call it optimistic stabilization strategy. So basically, as soon as the configuration of the resource is complete, so that's probably if you do the create API call for a resource, then they proceed with the next step already, instead of waiting for the whole thing to be totally available. And they then hope that the resource gets stable at the end, and if not, then they roll back the other thing. So that's, I think, I think it sounds reasonable, sounds cool. And first of all, I'm really happy that someone is working on CloudFormation and is improving things under the hoods. So that's really good news in general. So and I then thought, so you know that I'm always a little skeptical if AWS says up to something. So they say up to 40% faster. So I investigated that a little bit. So, and we create a lot of CloudFormation stacks with our acceptance tests that you have been talking about. And I looked into some of those stack creations. And to be fair, so the data that we have is going back, I think, 14 days or something. So I don't know when they exactly released the change. So it's possible that they released it 4 weeks ago and now they are announcing it. I don't know. Probably not, but it's possible. So what I found out is a typical stack that we deploy includes about 60 resources and so EC2 instances, IAM roles, Lambda function, stuff like that. And it typically it took so 2 weeks ago, it took about 230 seconds to create. And now, so yesterday and the day before, so after the announcement, it took about 211 seconds. So this is an improvement of 8%. So yeah, so it's definitely up to 40%. 8% is in the range of 0 to 40%. So it's totally fine. So maybe there are other scenarios where you have, I don't know where the effect is bigger than what we see here, but yeah. So we observe an improvement of 8%, which is still a cool thing, I would say. So 8% is better than nothing. So I'm still happy with the announcement. Okay, so the next one, Michael. Amazon RDS now supports IO2 block express for consistent sub-millisecond latency and 99.999% durability.
Okay. I mean, I just know that IO2 block express volumes can be kind of attached to multiple EC2 instances in the same availability zone, if I remember correctly. So I'm not quite sure.
Yeah, I think
how it works here with RDS.
I think the main feature of IO block express is you get a really, really consistent IO latency and a very low latency as well. So it's really consistent and really low latency, and that's the thing. And it's expensive. So it's really for high critical workloads for big databases. But one thing caught my attention. So that's not, so okay, that's great. I will never use it probably because I don't have such a system running on RDS. But what I found really, really cool is the following. It says you can upgrade an Amazon RDS database from IO1 to IO2 block express without any downtime. So I found that really crazy. So if you think about the system that can be run on such storage, so I don't know with how many throughput you get, but it's really amazing. And you can just switch that to the new storage layer and it works without any downtime. So if that's really the case, that's really amazing, and they probably invested a lot in making that happen. I assume. Okay, so one more small announcement is AWS WAF enhances rate-based rules to support configurable time windows.
Yeah, that makes a lot of sense.
It makes sense. And I remember that when I was using WAF, I basically was running exact into that issue, because back then you had a fixed 5-minute window when aggregating requests to evaluate rules. And this was for low traffic websites. This is too less time to look into, and for high volume workloads, it's too much. So now you can configure it, and you can select 1, 2, 5, or 10 minutes as an aggregation window. So I think that's a interesting thing, and probably many that are using WAF can make use of that. Okay, Michael. So this was a lot of fun. Thanks for talking through those AWS news again.
Yeah,
That's it. We will be back soon. Subscribe to our newsletter, podcast, or YouTube channel to make sure you're not missing the upcoming shows. We are also looking forward to your feedback. hello@cloudonaut.io, or find us on LinkedIn or Mastodon. As always, you will find all the links in the show notes and the video